The final lesson of Unit 6 isn't anything really new other than giving special names to something, and it's called even and odd symmetry of functions. And once again, symmetry means to be even on both sides of something. So the first symmetry we're going to look at is even symmetry, and that is right here on our left. Even symmetry means we reflect over the y-axis. And you know what happens when you reflect over the y-axis. The y values stay the same, but the x values switch signs. So we have there in our picture a degree of 4 polynomial that is evenly reflected over the y-axis. And you can see that I chose a point, 1, 3, reflected over the y-axis. We see it's negative 1, 3, because when you reflect over the y-axis, I'll say it one more time, you negate the x. So algebraically, even symmetry means that if you plug a negative x value into a function, you get out the same answer as if you plugged x in, right? Put a negative x in, you get the same y's. Odd symmetry is reflect over the origin. That means both the x and y values switch signs. So as you can see right here, if I had the point 1, negative 5, when I flip it over the origin, it becomes the point negative 1, positive 5. Both the x and y values change. And there's a little silly saying we have for this one too. It's the O symmetry. Odd over the origin, opposite. So once again, I always try and tell you the stupid little things that I had my brain do when I was in high school, and that was the O symmetry, a bunch of O's together. And that means you would have to say, okay, if I put a negative x into my original function, then out will come the negation of my y's original. So we'll get more into these in a second. Okay, so now we're going to address those algebraic proofs of even and odd functions. They're not like your geometry proofs that you did last year because you don't have to put any words behind them. It's algebraic, so all you have to do is kind of just show your math. So first off, to prove if something is even or odd, there are 2 ways to do it. One is kind of the cheater's way. You throw it on Desmos and you look at it. And we're going to look at this first one right here, x squared minus 4, and you go, yeah, that's even. That's the definition of symmetry above around the y-axis. But to do that algebraically, what you need to prove is that when I put a negative x into the function, it will equal the same as if I put a positive x into the function. So that's what we're going to do. We're going to take this function and in for x, we are going to put a negative x. And that answer should be the same as if we had our original function. We put a positive x in. And you can see when you do it, negative x squared is positive x squared minus 4. And that does indeed equal x squared minus 4. Now, I should put a little question mark here because it's a proof. We're trying to show that one side of the proof does indeed equal the other side. So in other words, we weren't given equalities in the beginning. We were trying to prove that the left side equals the right side. And then when we do our proof, we give it a little check mark that yes, indeed, this function right here was an even function. Likewise, with an odd function, I'll throw it on Desmos. It does look to be odd. The ooh is happening. It does look to be odd because it's over the origin. Now, what about that opposite that I was talking about? Where does that come into play? Well, it comes into play this way, the same thing. The odd says that if I put a negative x into my function, out will come a negative y. Get it? The opposite. So once again, I'm going to start like this. In for x, I'm going to put negative x. And that should equal, when I'm done, the negation of the original function. Well, negative x to the fifth. We have to remember that anytime we raise a negative to an odd power, it is negative. Negative times negative is positive. Now, does that equal, when I distribute that negative, negative x to the fifth plus 4x? Yes, it does. I'm able to come back here, erase that, and put a check mark. So what about this one? X cubed minus 4x squared, it doesn't look to be even or odd. And yes, you can have neither. Right? A function does not have to be even or odd. Being an even or odd function is a special attribute to it. So once again, if I were to do this, if I were to start with the even first, you would have to prove that it's neither even nor odd. So even was, when I put negative x in, I get the same thing back. That makes it even. All right, so I'm going to come over here. I'm going to set up my template. And I'm going to put in a negative x. And does that equal the original function of x cubed minus 4x squared? Negative x raised to the third power is negative x cubed. Negative x squared is positive x squared. But then when I multiply by negative 4, I get negative 4x squared. Does that equal x cubed minus 4x squared? Almost. But unfortunately, we can see we have a negative x cubed and a positive x cubed. So therefore, we can come up here and we can replace that with a not equal sign. So now the last thing we got to do is odd. Okay, so for odd, we've got opposites going on. Remember that if we put in a negative x, out will come a negative y. Now, just to go back to this picture over here, that's what it says right here, right? If I put in a negative x, out will come the negative of the original y. All right, so let's see if that happens. Put my template up, x cubed, and it's going to be 4x squared, and does that equal x cubed minus 4x squared? All right, let's throw in what we're looking for. We're going to put a negative x in here, and we're going to negate the entire, and we're going to see if that does indeed equal. Well, a negative raised to an odd power is negative. Once again, negative x squared is positive x squared. Positive times a negative is negative 4x squared. Does that equal the negation? Negative x cubed. Looking good. Aw, negative times negative is positive 4x squared. Therefore, we replace with a does not equal. And here's a little thing. This is how we abbreviate the word therefore. And we just say that this function is neither odd or even. That's all. Tomorrow. For now, this is your summary of the lesson. Even symmetry means we're reflected over the y-axis, and when we reflect over the y-axis, that means the x's change to negatives. Odd symmetry means we reflect over the origin and we get opposites. When we put in a negative x, out will come a negative y.